an individual spent 5 years at university and experienced some career setbacks. Following this, they pursued an electrical apprenticeship. They were inspired by their passion for the trade. The individual returned to the electrical field, and that's where they currently work. Electrical apprenticeships typically involve a combination of on-the-job training and classroom instruction. The specific requirements and duration of an apprenticeship can vary depending on the location and the specific trade. Generally, an electrical apprenticeship program teaches the fundamentals of electrical theory, safety practices, and the installation, maintenance, and repair of electrical systems. Some key skills that are developed are reading blueprints and technical diagrams, installing wiring and electrical components, troubleshooting electrical problems, and adhering to electrical codes and regulations. Furthermore, understanding safety protocols is paramount in electrical work. Apprentices learn about personal protective equipment, lockout-tagout procedures, and how to work safely with electricity to prevent accidents. They also learn about the National Electrical Code, or NEC, which sets the standard for safe electrical installations in the United States. The NEC covers topics such as wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential for ensuring the safety of people and property. In addition, electrical apprentices gain practical experience by working alongside experienced electricians. They assist with a variety of tasks, such as wiring buildings, installing lighting fixtures, and troubleshooting electrical problems. Over time, they develop their skills and knowledge under the guidance of their mentors. Some common tools and equipment used by electricians include wire strippers, pliers, screwdrivers, conduit benders, multimeters, and voltage testers. Apprentices learn how to use these tools safely and effectively to perform their work. An important aspect of electrical work is understanding electrical circuits. Apprentices learn about series circuits, parallel circuits, and combination circuits. They also learn how to calculate voltage, current, and resistance using Ohm's law. Ohm's law states that voltage equals current times resistance. This fundamental principle is used to analyze and troubleshoot electrical circuits. Another important topic is overcurrent protection. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect electrical circuits from excessive current flow. Apprentices learn how to select the appropriate overcurrent protection devices for different circuits and applications. Grounding is another critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to prevent electrical shock. Apprentices learn how to properly ground electrical systems and equipment. Furthermore, apprentices learn about different types of wiring methods, such as conduit, cable, and raceway. They learn how to select the appropriate wiring method for different applications and how to install wiring in accordance with the NEC. In addition to technical skills, electrical apprentices also develop important soft skills such as communication, problem solving, and teamwork. They learn how to communicate effectively with clients, coworkers, and supervisors. They also learn how to identify and solve electrical problems in a timely and efficient manner. A typical electrical apprenticeship lasts for 4 to 5 years. During this time, apprentices receive a combination of on-the-job training and classroom instruction. Upon completion of their apprenticeship, they may be eligible to become licensed electricians. Licensing requirements vary by state, but typically involve passing an exam and demonstrating sufficient work experience. Licensed electricians are qualified to work independently and to supervise other electricians. They are also responsible for ensuring that their work meets all applicable codes and regulations. Continuing education is an important part of being an electrician. Electrical codes and technologies are constantly evolving, so electricians need to stay up to date on the latest developments. There are many opportunities for electricians to pursue continuing education, such as attending workshops, seminars, and online courses. Some electricians choose to specialize in a particular area of electrical work, such as residential wiring, commercial wiring, or industrial wiring. Specialization can allow electricians to develop expertise in a specific area and to command higher salaries. The electrical field offers a wide range of career opportunities. Electricians can work for electrical contractors, construction companies, manufacturing plants, and government agencies. They can also start their own electrical businesses. The demand for electricians is expected to grow in the coming years as the population grows and as new buildings and infrastructure are constructed. There are several different types of electrical systems. Residential electrical systems are used in homes and apartments. They typically include wiring for lighting, appliances, and outlets. Commercial electrical systems are used in businesses and office buildings. They are typically more complex than residential systems and may include wiring for HVAC systems, security systems, and data networks. Industrial electrical systems are used in factories and manufacturing plants. They are typically the most complex type of electrical system and may include wiring for heavy machinery, automated systems, and process control equipment. When working with electricity, it is important to always follow safety precautions. Always turn off the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment. If you are not comfortable working with electricity, hire a qualified electrician. There are many resources available for electricians, such as the National Electrical Code, electrical textbooks, and online forums. These resources can help electricians stay up to date on the latest codes, technologies, and best practices. Apprenticeships are a great way to learn a skilled trade and to earn a good living. If you are interested in becoming an electrician, consider pursuing an electrical apprenticeship. It's important to understand several factors regarding electrical systems. The voltage in a standard residential outlet in North America is typically 120 volts. However, some appliances, such as dryers and ovens, require 240 volts. The amperage of an electrical circuit is the amount of current that flows through the circuit. The higher the amperage, the more current that flows. The resistance of an electrical circuit is the opposition to the flow of current. The higher the resistance, the less current that flows. Electrical power is measured in watts. Watts are equal to voltage times amperage. The NEC requires that all electrical work be performed by qualified individuals. This is to ensure the safety of people and property. When selecting electrical equipment, it is important to choose equipment that is rated for the voltage and amperage of the circuit. It is also important to choose equipment that is listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. When installing electrical wiring, it is important to follow the NEC. The NEC specifies the type of wiring that can be used in different applications, the size of the wiring that is required, and the methods for installing the wiring. When troubleshooting electrical problems, it is important to start by identifying the symptoms of the problem. Then use the multimeter to test the voltage, current, and resistance of the circuit. This will help you to isolate the cause of the problem. Before beginning any electrical work, always disconnect the power to the circuit. This will help to prevent electrical shock. When working with electricity, always wear safety glasses and rubber gloves. This will help to protect you from electrical shock and burns. If you are not comfortable working with electricity, hire a qualified electrician. There are many different types of electrical connectors. Wire connectors are used to connect wires together. Conduit fittings are used to connect conduit together. Cable connectors are used to connect cables to equipment. When selecting electrical connectors, it is important to choose connectors that are rated for the voltage and amperage of the circuit. It is also important to choose connectors that are listed by a recognized testing laboratory such as UL. When installing electrical connectors, it is important to follow the manufacturer's instructions. This will help to ensure that the connectors are properly installed and that they will provide a reliable connection. Electrical boxes are used to enclose electrical connections. Electrical boxes protect the connections from damage and prevent people from coming into contact with live wires. When selecting electrical boxes, it is important to choose boxes that are sized appropriately for the number of wires and connectors that will be installed in the box. It is also important to choose boxes that are listed by a recognized testing laboratory such as UL. When installing electrical boxes, it is important to follow the NEC. The NEC specifies the type of boxes that can be used in different applications and the methods for installing the boxes. Electrical panels are used to distribute electricity throughout a building. Electrical panels contain circuit breakers or fuses that protect the circuits from overcurrent. When selecting electrical panels, it is important to choose panels that are sized appropriately for the electrical load of the building. It is also important to choose panels that are listed by a recognized testing laboratory, such as UL. When installing electrical panels, it is important to follow the NEC. The NEC specifies the type of panels that can be used in different applications and the methods for installing the panels. Lighting fixtures are used to provide illumination. Lighting fixtures are available in a wide variety of styles, sizes, and wattages. When selecting lighting fixtures, it is important to choose fixtures that are appropriate for the application. It is also important to choose fixtures that are energy efficient. When installing lighting fixtures, it is important to follow the NEC. The NEC specifies the type of fixtures that can be used in different applications and the methods for installing the fixtures. Appliances are used to perform a variety of tasks such as cooking, cleaning, and entertainment. Appliances are available in a wide variety of styles, sizes, and wattages. When selecting appliances, it is important to choose appliances that are appropriate for the application. It is also important to choose appliances that are energy efficient. When installing appliances, it is important to follow the manufacturer's instructions. The NEC covers various aspects of electrical installations, including conductor sizing, which is detailed in tables such as NEC Table 310.15b16. This table provides ampacity values for insulated conductors rated up to 600 volts based on their insulation type and ambient temperature. For example, a 12 American wire gauge or AUG copper conductor with type THHN insulation, which is commonly used in residential wiring, has an ampacity of 30 amps when installed in a raceway or cable. However, the actual ampacity may need to be adjusted based on factors such as ambient temperature and the number of conductors in a raceway. Voltage drop is another important consideration in electrical installations. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, it is important to use conductors of sufficient size and to keep the length of the conductors as short as possible. Ground fault circuit interrupters, or GFCIs, are devices that protect people from electrical shock. GFCIs monitor the current flowing in a circuit and trip if they detect a ground fault, which is a leakage of current to ground. GFCIs are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, or ARFs, are devices that protect against electrical fires. ARFs detect arc faults, which are dangerous electrical discharges that can occur when wires are damaged or connections are loose. ARFs trip the circuit if they detect an arc fault, preventing a fire from starting. Surge protective devices, or SPDs, are devices that protect electronic equipment from voltage surges. Voltage surges are sudden increases in voltage that can damage sensitive electronic components. SPD divert the surge current to ground, protecting the equipment.